Е, да микрофон, да?
Чак, сега ще ви дадеш.
Okay, I guess I'll start. So, hello everyone, thank you all for coming. I'm really happy you chose to be here this early on a Saturday. So yeah, thank you, and I'll start. First, a quick introduction about me. My name is Ilyazov. I work at Ilyazov as a team lead currently. So a few words, like I'm passionate about event-driven architectures, about anything related to DevOps. I like to see the full picture of what we're developing. I'm really keen on mentoring. My favorite question could be, how does this actually work? Followed secondly by, why does this actually work normally? And yeah, if I seem pale, I didn't sleep very much. Okay, so what is this talk about? I left the title really a bit vague, just because I think annotations in Java are something really nice, but not a lot of people know how they're actually implemented, so it all seems a bit magical. And I wanted to show basically for everyone who doesn't have much of an idea what there is at the end, but that will be a bit further down the line. And yeah, it's a bit of a clickbait title. Okay, so let's play a game. I'll show a few annotations, and I will ask you to raise your hand if you've used this annotation, for all of the Java developers here. Transactional, has anyone used this one? Yeah? I assume you had some database inconsistency issues, then this fixed the issue. Service? Yeah? I assume you didn't know what the difference with component annotation was, but it seemed cool. So nice. Then request mapping, for everyone who hadn't heard of post mapping still. The deprecates annotation. Okay, not a lot of people have seen this one. Has anyone actually written this annotation, implemented it? Yeah. So if you've seen any method which was strike through, then that means you shouldn't really use that method. That's what this annotation is about. This one, suppress warnings. Okay, almost everyone, nice. And the next one, sneaky throws. I assume not everyone will admit, but okay. And then I think the order actually means the more likely you are to use it, which is at the top. Okay, so what annotations remind me about is when I was a little bit younger, I used to play a game called Grand Theft Auto, GTA, and then there were all sorts of cheat codes. You just remember the cheat code, you type it in, and then some magic happens. Like this one, where it gives you money. And this one, where it just fixes everything. How many people have used these cheat codes in GTA? Nice. How many people use annotations like the cheat codes in GTA here? No one, okay. So yeah, first we'll do a bit annotations 101. I will try to explain what annotations are. So we're all on the same page. Okay, Java annotations are a powerful feature that allow you to add metadata to your code. Metadata means basically data about your data, or as my professor used to say, данна за вашата данна. Annotations provide a way to associate information with your code that can be used at runtime or during compilation, or even just for your eyes to see. They're basically defined using the @ symbol followed by the name of the annotation in Java. They can be used to improve readability by adding additional information. and to add functionality, but secretly, like the cheat codes. This is not really something specific, by the way, to Java. Even C# has them, but they're called attributes. So the Java implementation is better as always. Okay, so an example here is the override annotation. The override annotation is mainly there to add additional context for the reader, just so you know that you're overriding a method using polymorphism from some kind of superclass. But actually it also will give a compilation error if you misuse it, like if you change the name of the signature in some kind of way. So to create an annotation, actually, what we need to do, we need to create a special kind of interface. An interface where we put the @ symbol before the interface keyword. So this is a new keyword, I guess. And then it becomes yellow. It seems nice. And then you can create a class. Sorry. And then just use your annotation. By the way, anyone can interrupt me and ask any questions at all times. And then what else we can do? Because like this, it's actually really vague. You can actually put this annotation everywhere, but you can also define the target, like where you want this annotation to be explicitly allowed. So in this case, in this example, we say I want this to be on type, so we want this to be on classes, and then methods. So in the example you see it's defined on a class, on a method it's fine, but if you put it on a field then we get a compilation error. And then a bit more interesting option is specifying the retention policy. So the retention policy lets us control the lifetime and visibility of the annotation. What that basically means is when will this annotation be removed from the code, the bytecode, at runtime, whatever. So there are 3 types of retention policies defined. The first, I guess, is the source level, where this has the smallest lifetime. This is available only at source level. What this means is when we compile the code and we get bytecode, and we get bytecode as a result, that bytecode doesn't have the annotation that we used on the class, the methods, or whatever. If it's a class retention policy, then it's available to the compiler and it's present in the generated bytecode. So the source level would normally be used by the compiler for some kinds of annotation processors that we will look at. The class level is mostly, I think, used by static analysis tools like SonarQube or SonarLint, because after the compilation phase, if you keep it in the bytecode, it doesn't really bring anything much to you as developers normally. And then runtime. In runtime, it means basically the JVM has access to it, and you can read the annotations, so you can read the metadata at runtime in your applications. I didn't sleep, as I said. We can also define fields in annotations, like this. So here, there's defined field called value, and then we can put some kinds of values and pass them when we're using the annotation. And we can do some more things. Like, for example, the documented annotation means if we generate Java code of our classes, then the annotations will be visible. The inherited annotation, if we put it as an option on a custom annotation that we define, that means we can actually use something like inheritance, and we can do composite annotations where we put a few and then merge them all together in a single sub-annotation or something like that. And the repeatable option, which basically makes it so you can repeat the same annotation on the same level. For example, on a method, you can use the same annotation 2 times. And yeah, now I'll do a quick demo. Okay. Is this readable? Let's see. Гадно бяло.
Гадно бяло се вижда. Кажеш, че знаеш как се прави това.
Горе Дракула.
А,
This one?
красота. Нека да бъде ден.
Okay, this threw me off. I'll need to do a hard reboot later. Okay, so this is a multi-module project where I have a few examples. First we'll look at the first part, which is a super simple annotation. So Martin Fowler will be really mad at this Java doc, but yeah, this is an annotation we have defined. So we can define a class, some kind of class inside, simple class, I guess, and then we can use this simple annotation like so. And I'll just show those options like the target. You can specify the element type. You can say, I want this to be used only on a method or something. Like so. And the retention policy, by default, is class if you don't define anything. So what this means is, let's open the terminal. Okay, let's do this. Okay, I can make this bigger. Okay, nice. So if we compile this, what we get in the end, it's simple class, and you see the annotation is not really there. If we make the annotation source level, it's such. It's again not there. Okay, this is good. Oh, interesting. Yeah, I'll have a look at that later. Okay. The repeatable annotation I will show in a bit. So later I'll show a demo on the runtime annotation, but just for this sake, I'll show how to do a composite annotation. Here I defined a repository about some customers, like such. This is running on a database, like a MySQL database. This is defining controllers, so we can access this resource. Let's see if it works. Yep. Okay. And how we would make this a bit more readable, but it's up to, it's always up to, yeah, personal, we can say, let's suppose you can just use it in here. You see here, it's already, it has the inherited annotation, so we can inherit it as such. We need to actually make the annotation first. And then we can just use that rest repository. And then hopefully it will start working. Okay, and the repeatable annotation, how it would look. I mean, the implementation is a bit like this. For example, API response is something we can repeat. And that's because it has the repeatable annotation. And to implement this actually, the repeatable annotation expects a class which extends an annotation. So we need to provide some kind of another annotation which has an array of the annotation you want to be repeatable as such. This is how you would implement it. Okay, any questions? Okay, so. Okay, let's continue. Did you notice how the annotations we played around with wasn't actually any useful at all? It just says simple annotation at the top, but it doesn't really do anything. So how does this, I guess, actually work? And how are cheat codes implemented in Java? It's magic. No. Okay. But you would hope it's a bit like magic when you actually see some code. So I would say you can believe it to be the same. Yeah. Anyone use reflection? This is actually partially true. But if you ask any kind of a senior developer or anything in the Java world, or you just Google around, Java reflection is the devil. But it's actually really used a lot. But normal people don't use it, just psychopaths. So yeah, I'll do, let's see some psychopath code. Okay, let's see it again. First, let's look at a compilation time example. For example, this annotation. It says at immutable, what I would like it to do is to put it on some kind of a class and then hope it should be immutable. But no, it won't be, of course. You could actually write the code to do that, but what I wanted to do with this example is to enforce a certain set of rules, because that's one of the cases where you would use annotations and annotation processing in general. What annotation processing means, before I get ahead of myself, is basically all of this metadata that you provide. If you want it to be actually useful, you need to read that metadata in some kind of way. So if your annotation is a source level, you need to read it before the runtime. So you need to read that metadata and then do something about it during compile time, which doesn't really give you a lot of options, but we'll see what the options are. But if it's runtime, then that means you can do some really dynamic stuff during runtime. But as people say, it's the devil. So how do we make this annotation enforce a certain set of rules? And so what we would like is, in this example where we have an immutable class, a final class with a final field, we want this to be okay, we want this to compile. And then we have a mutable class, which is not a final class, so it can be extended. It doesn't have any final fields. This has this one, and for increased spice, I added a long box setup. Just for the heck of it. Now, if we recompile the immutable class. Let's see the result. Okay. Let's hope the demo gods are with me. Mm-hmm. Okay, this one was fine. It compiled. Then if we try this one, immutable class, it failed with a compilation error. And it says class annotated without immutable must be immutable. So how do we do that? The magic is not really pretty. What we need to define is an annotation processor, which is something that extends an abstract processor, which is an abstract class we need to define. You can override all sorts of methods inside, you can do all sorts of things, but the main thing is overriding the process method. So the process method gets all of the annotations and the round environment. Round environment is basically the compilation phase in Java is not really a one-time thing. It happens actually in rounds. So what happens is a compilation phase starts and it goes and does a bit of processing and then starts from the beginning, and then it does another batch of processing, and the round environment basically is an interface to get all of the information in that environment. So what we're doing here is we're getting all of the annotations that we have in the environment, and then we're getting the element that's in the round environment at the time. We check if it's of type class, and we check if it's immutable. Wait, some really strange code. So what you have working with here is not really your code itself. We have elements from which we can get the simple name, for example, of a class. We can get all of the modifiers like final, static, etc., etc. We can get the fields, enclosing elements. So we need to go through this kind of an interface to get all of the enclosing elements. We check if the kind is a field of an element. We check if it has the final modifier. We check if it's immutable, and it's all a lot of code that we don't have time to have a look at. But that's the way that we need to process this, and it's not really easy to debug because this is not in the runtime. This runs when you compile the code. So the annotations that you see here are basically, again, they can be skipped, but what they mean is the support annotation types basically specifies what annotations we want to support with this one. With this annotation processor, you need to give a full path to it. The latest supported source version where this was tested, basically, so this is more of a promise than anything else. And this one is a bit of magic. So the auto-service annotation is basically something provided by Google. It's an annotation that does, again, some magic behind the scenes. What it basically does is it creates this meta-inf folder with services. This file, which you can notice that we're passing the same processor to that annotation. So it's providing this information and a path to all the annotation processors that we defined here in the code. And the compiler will have a look at this, what we have defined here, and then it will search for those. So this is a bit of a, let's say, helper annotation, so we don't need to define that ourselves. What we would need it to do if we didn't have that, we can pass annotation processes to Maven like this, and then path like such. That again would help Maven to try and find this annotation process to do its job. And that's it for the example for compile time annotations. As you can see, this is a really simple example, but what you can do normally, so with the compile time annotations, I'm sure most of you imagine Lombok, which I've used here. What Lombok does, as most compile time annotation processes, is actually generate code on top of your code. And how that is done, because in this example we're just checking some meta information, but how normally you generate setters, getters, builders, and things like that is using this interface, which is called a filer in the JavaX annotation processing. And what it gives you are methods like create source file, create class file, create a resource, and then get some kind of a resource. So the normal way to actually generate a builder pattern, for example, to be able to do something like this would be to have an annotation processor that will read this class, and then it will generate a new class, and then add all of the code inside that new class. And then you would need to use the new class that you provided. It's a bit like the mapstruct library, if you've ever used it. You need to basically use the generated classes instead of the ones that you had before that. But I'm sure all of you have noticed, if you use Lombok, that's not really the case. You can just add a setter here, and then you can use the same class, and it will have those methods. And that's why Lombok is really controversial. It's controversial because what Lombok does is it changes your own code. So a lot of people find that really intrusive. But it's all personal preference. In my opinion, they can intrude all they want. Okay, now we don't have much time, so let's go to runtime annotation. Here we have again the same example where we have the customer repository. We have a customer, and what I wanted to do is to add a test. This is the customer repository test. Normally, what I would have needed to do, for example, is if I want to test any kind of a find out operation, you would need to first create a new customer, for example, set some values. And then save that customer to the database before testing the find all operation. But what you could use sometime annotations for is basically something like this. I defined an annotation called insert entity. It's actually in a library that I defined. Sorry. So in it, I pass an entity type, which is a class. I pass some fields to skip, for example, an auto-generated ID that I don't want to be filled in. And optionally, I define how many of those entities I want to come in. And since I don't really know the type of the entity beforehand, and I don't know what kind of fields it has, I just randomize all of the data. So what this annotation will do is it will get the metadata from this annotation before the class. It will find all of the fields that we have in the customer, and then it will generate some random values and then pass them inside. And I can basically define how many elements I want to pass inside and where all of the time. So let's look at how that's implemented. So for the case of the test, I'm using test execution listener to inject some code before and after some test methods. After the test, I delete everything in the repository, and before the test, we're using reflection to get the information about the class from the application context we're getting from, using the entity type and some literals like the repository to find the bean that we actually want. That is defined in the context. We're parsing that and mapping that into a bean. We're getting the fields to populate. And then with some really pretty code, we're seeing if all of the fields, what type they are, and then we assign some random values to them. And yeah, it's not pretty. And it's not pretty, but it does the job, I guess. Okay. Continue really fast. So yeah, do not try this at home, just a disclaimer. I will not be responsible for anything you break. When you should use annotations, just for adding some readability. As I said, for enforcing some rules, like with the immutable annotation, you can enforce rules in your code base to strictly follow some principles. Or if you want to build a library, like the whole Spring framework is built on top of reflection and annotations. When you shouldn't use annotation processing, almost always. Like you have to use it, if not, just don't. Last thing, I wanted to leave you without promoting anything, but on Thursday, I asked my boss, his name's Alexander, he's outside. I asked him if he wants me to promote anything. I hoped I would save you the trouble, but no. He said, yeah, I want you to promote something. And he sent me this. Let's have a look. So this is a grater. And for all the 1 or 2 people that don't know Bulgarian, what this is basically the newest burner grater from Germany. It's the best grater of all time. It's a universal, so this is the description that it says, a universal 4-sided grater for processing of vegetables, cheese, and cheese again, so it's really good with cheese, chocolate, fruit, and much more. 10 out of 10 I would recommend, but you won't be able to find it. Alexander really wanted this grater, but he said he looked everywhere and he couldn't find it. So let's make a wish. Please help us find that grater. Yeah, thank you for your attention. The code will be available using that QR code or that link in half an hour. So yeah, I don't think I have time for questions. You can find me outside. Oh, does anyone have questions? I guess not. Okay.
Използвате ли анотация реално в проекта, в който работите?
Използвал съм анотация в предишен проект, където работих. В смисъл, runtime анотацията, която показах, е доста... нали, не е много добър пример, но много късно видях, когато почнах да правя демото, че всъщност ще е много сложно да покажа реалния пример, който съм правил в работен проект. Там нещо, което правихме, ползвахме DynamoDB, втората версия на API. Това е NoSQL база от AWS и те нямат Spring Data JPA. Hibernate имплементация на втората версия, която е с Reactive. Това какво означава? Това означава, че когато пишеш тестове или като цяло, няма да ви се създаде таблицата автоматично. Няма да се изтрие таблицата автоматично, нямаш create, drop, update и така нататък. Там се наложи да напиша цяла библиотека, която репликира с едно JPA репозиторито с всичките find all, operation и така нататък. И съответно написах и тест това библиотека, където да можем да кажем това ни е entity класа, пращам някакви пътища с JSON и искам тези неща да влезнат в базата, нали само за тестови цели и така нататък. Там доста се наложи да си поигра. И защо казвам, че не е добре да го ползвате Reflection като цяло, защото наскоро гледах един подкаст на Лекс Фридман с Джеймс Гослинг, който е създател на Java. И той какво каза? Не за Java, а защо е тръгнал да пише Java, защото почти всички проблеми, които се сблъскваме с C и C++, са заради, с негови думи, stupid pointer tricks. И да ползваш Reflection в Java е малко като да правиш stupid pointer tricks. Трябва да си много експлицитен за всичко се чупи. Това, което ви показах с inherited анотациите, ако си поиграем малко повече и го inherit, можете един път, нормалният интерфейс на Reflection няма да ви даде, няма да стигне до второто ниво на суперкласа да ви даде анотацията да я намери. И тогава трябва да правим други глупости, че да му да намерим и да вървим нагоре по линията и ужасно пипкаво е реално работа. И така, да.
Колко колеги си видял да не могат да ползват анотации, че реши да направиш тази лекция?
Много. Ама то не е ползване, то е създаването. По принцип не съм засичал много колеги, които са създавали и не съм и виждал много лекции по съответната тема. Им се видя като забавна тема и за това. Да. Добре, мерси. Да.
Може ли да повториш въпроса за канала?
Да. Значи въпросът беше в практика дали съм засичал негативи, които сме срещали при използването на анотации и естествено основният негатив е, че доста хора влизат, пишат имам проблем, влизат в Stack Overflow и анотация. Втора, трета, четвърта, пета, пробват тази анотация, другата анотация, никой не чете в Java до какво пише за тази анотация. После сменяме версии, например с Swagger UI, ако са ползвали, сменяме версията и после 15 различни анотации, всяка различна версия. И основният проблем е, че стават магии, никой не разбира защо и само правим trial and error с различни неща, които намираме с такова хора. Това е основният проблем. Да.